Hi guys, Sajjad Hussain again with a new video. Actually, this is not a new video, I can say. This is in continuation with my last video. In my last video, I discussed design of a 4-story building, and I took the example from the book Design of Low-Rise Reinforced Concrete Building. This is based on IBC 2009, ASCE 705 and ACI 31808. This book is written by David A. Fanilla, and I took this example and I prepared my last video. Let me show you what I did in my last video. This is my channel. This is my last video, 4-story residential building designed by ETABS. So what I did, I used ETABS.
So let us start
this building
model.
The plan of the building is shown like this, and then I modeled this building in ETABS. And
we will go to File, New Model.
And I check the results from ETABS to the actual.
Our built-in settings are units, US customary, that's correct, and concrete design code is ACI 31808.
It will be very clear to you what I was talking about in this video and now what I'm going to talk
now here
in this particular video.
we can easily model because we have one type of
that building which I would design in this last video was a seismic design category B building. That means what I discussed was applicable for the design and detailing of a seismic design category A and B building. Then I received some questions. The questions were asked that please explain what are SDCs, how many SDCs are there, what is the meaning of SDC A, B, C, D, E, F, and for a young engineer, what they should do if they are designing a building for seismic design category A or B, or what additional requirements are imposed if the building lies in seismic design category C, or if it lies in seismic design category E, and then others. But now my emphasis is what I want to make clear, that if you are designing a building in seismic design category A and B, where the minimum requirements are there, what you have to do. So let us first understand what are these SDCs. Seismic design categories are as per the code ACI 318 and chapter is 21.2. So let us go to the code and let us understand what is the meaning. This is ACI 318. It's chapter 21. Its paragraph is 21.1.1.2. It says that all structures shall be designed to a seismic design category in accordance with 1.1.9.1. Okay, and then all members shall satisfy requirements of chapter 1 to 9 and 22. Structures assigned to seismic design category B, C, D, E or F shall satisfy para 21.1.1.4 through 21.1.8 as applicable. So seismic design category A means this is an ordinary structure designed as per 318 only. No need to follow chapter 21. But for chapter 21, which is applicable for SDC B, C, D, E and F, so what we have to do? So its para 21.1.4 says structures assigned to SDC B shall satisfy 21.1.2. then SDC C shall satisfy 21.2 and 21.8. That means 21.8 should also be followed if it is SDC C. And if it is SDC D, E or F, then not only 21.2 and 21.8, rather the additional paragraphs like 21.11 through 21.13 should also be followed. Now the questions one can ask that what are the requirements in para 21.2 or 21.8 and 21.11 or 12 or 13. So let's see 21.1.2. 21.1.2 says analysis and proportioning of structural members. So that means this portion of the code is applicable for the method of analysis and proportioning of the structural members. So one can go through in details what are there, but normally if I am following a software, like either I am following ETABS or I am following SAP 2000 or I am following STAD or TECLA, we assume that they are following these steps. But if you are designing a particular structure, then you must check your output because you are the engineer on record, so you will be held responsible for the mistake if it is done at any stage. That means you have to check these requirements very carefully and you have to see whether these requirements are met or not. In general, all these software, they meet these requirements. But be careful, at least you should have an eye on it that all these requirements is mentioned here are met by the software. So having a clear concept of SDC A, B, C, D, E and F, etc., the requirements to be followed and the paragraphs are also mentioned over here. Let's go back to our problem. This problem stated that this structure lies in SDC B category. Then the question was, what are the provisions? So following are the examples of these provisions. Like for example, structural integrity reinforcement must be provided in accordance with ACI 7.13. The purpose of this reinforcement is to improve redundancy and ductility, especially in structures subject to abnormal loading events where major supporting elements may be damaged. This is a very important paragraph. Why? Because if your structure is not ductile, then in case of an earthquake, the failure will be sudden and catastrophic. That means there will be no warning before failure. All of a sudden the structure will collapse, God forbid. Being a structural engineer, heavy burden lies on your shoulder that your structure should be ductile before failure. Enough time should be given. The warning should be there. Some cracking will be there. And the structure should not collapse immediately without giving any warning. That's why they say there should be redundancy and ductility. Let's go and see what this paragraph ACI 7.13 says. Let me go to the code, chapter 13. Sorry, 7.13, not 13. Here is 7.13. Requirement for structural integrity. That is very important thing. Your structure should remain integral in case of an earthquake. It says in the detailing of the reinforcement and connections, members of a structure shall be effectively tied together to improve integrity of the overall structure, especially your columns. The next is for, for cast in place construction, following shall constitute minimum requirements. So there is a list of minimum requirements provided, and you should go through it, all these requirements, and you should be very carefully, you should check very carefully that all these requirements are met before issuing your drawing. Because once you issued your IFC drawings, your building is going to be constructed according to your drawings. Nobody is going to check your calculation, but in case of any failure, you will be held responsible. So you should understand that to ensure the structural integrity, para 7.13 is very important, and not only you should rely on the software, you should also check all these requirements. I'm not going to explain you each and every requirement over here. My intention is to give you a concept that if you are a structural engineer, if you want to be a real structural engineer, then you have to check these values. You have to check these clauses. You have to check these paragraphs along with your output. Don't take the output guaranteed, and don't rely on the software directly. Yes, these are commercial software. A lot of work have been done. We appreciate their work, but they do not guarantee their output. It is the responsibility of the end user to make sure that the output is in line with the codes and standards. Now, next provision. Minimum shear reinforcement must be provided in accordance with ACI para 11.4.6. Such reinforcement is of great value in cases wherein member is subjected to an unexpected tensile force or an overload. So this para is very clear that you must provide minimum shear reinforcement, either in the beams, in columns, everywhere, in slabs. One very important point now, beam column connection. Normally people do mistakes over here. They overlook this point and they just rely on the output that okay, whatever number of bars are coming out of the resolve, they provide that one and they think the work is done. No, you have to check the beam column connection. It must have a minimum amount of lateral reinforcement where such connections are not confined by beams or on all four sides of a joint. This is as per para 11.10.2. Joints on the exterior of a building without lateral confinement need lateral reinforcement to prevent deterioration caused by shear cracking. So you must check that you are meeting this minimum requirement, especially for the connections. This is very important in case of earthquake. If you are not designing for lateral forces, okay, just you are developing your connection as per the standards, fine. But when you are dealing with lateral forces, you have to ensure that all your beam column connections are in line with the ACI para 11.10.2. Another provision is reinforcing bars must be spliced and anchored in accordance with the provisions of ACI chapter 12. Very important. Not only these splices, the location of these splices are also important. And if they are anchored, it should be properly designed. So you must follow the requirements of chapter 12. In order for a reinforced concrete structure to perform as intended, the reinforcing bars must be fully developed for all possible loading conditions. That means your development length, whenever it is specified, it should be specified properly. And what I will suggest, that please check the output of your software. Sorry. Check the output of your software. Wherever development length is there, you should verify manually. Now, beams, as part of the primary seismic force resisting system, must contain positive reinforcement confined to ACI, conforming to ACI 12.11.2. The proper anchorage of positive reinforcement at the support helps ensure a ductile response in the event of overloading. Another very important provision. Where beams, they must have positive reinforcement. Only negative reinforcement is not necessary. You must provide positive reinforcement, and you should follow paragraph 12.11.2. Just this is to proper anchorage of positive reinforcement at the supports, so that the bars should not slip off the support in case of an earthquake. It should be properly anchored. So these are the general requirements as per ACI code. And these are only for seismic category B building. I'm talking about only seismic category B building. That means where the earthquake is mild, not very severe earthquake. Another very important aspect which I wanted to discuss was the load combination. In my video, you will see that in this example, what they have taken some special load cases for in case of load combination number 5, they took the live load coefficient as 0.5. So what is here? The load combination for strength design or load and resistance factor design in IBC 1605.2 are to be used in design of reinforced concrete members. Now here I need to explain something. First of all, I have my code ACI 318, and I know that in ACI 318 para 9.2 it gives me the load combinations, where equation number 9.1, 9.2, 9.3, 9.4 and 9.5, 6 and 7. 9.5, it gives me a combination of 1.2D plus 1.0E and 1.0L and plus 0.2S, where the coefficient 1.0L is further explained over here. It says except as follows. The load factor on the live load in equation number 9.3 to 9.5 shall be permitted to be reduced to 0.5 except for garages, areas occupied as places of public assembly, and all areas where L is greater than 100 pound per square feet. If I go to IBC para 1605.2 load combination, same thing is there. 1.2D plus 1.0E plus F1 times L in plus F2 times S. What is F1? F1 is further explained over here, where F1 is equal to 1 for floors in places of public assembly, for live loads in excess of 100 pound per square feet, that means 4.79 kilonewton per square meter, and for parking garages live load, and it should be equal to 0.5 for other live load cases. That means in this particular combination, either we can have 1 L or 0.5 L. We are not talking snow load now, so it's okay. I'm not going to discuss F2, otherwise provision for F2 is also there. My concern is the coefficient which is used in this load combination particularly. If I go to ASCE 705, same thing is there. Equation number 5, 1.2D plus 1.0E plus L, again the coefficient is 1, but here the load factor on L in combination number 3, 4 and 5 is permitted to equal 0.5 for all occupancies in which L naught in table 4.1 is less than or equal to 100 pound per square feet. That means all my codes, either I am following ASCE 705 or I am following IBC 2006 or I am following ACI 31808. All three codes, they permit me to reduce the coefficient for live load in this equation to 0.5. Is it true for the ETABS which I used? Let's analyze. In my model, when I did that, I saw the load combination. So here is the table, load combination is there. In this load combination, all the load combinations are listed over here. So wherever live load comes, like for example here, this is 1.6, here 1, again 1, again 1 for seismic case, again 1, one 1.6, 1, 1, again 1, seismic, again 1, that means the live load is not reduced to 0.5 L. But in this example, they have used 0.5 with live load in this particular load combination. And when we define load combinations, for example, if I am going to define my load combination, if I say add default load combination, it does not ask me about this condition. It's just define the load combinations and take load combinations as 1L in all the load combinations. So I can say that although it is a little bit conservative, but it is not actual in as per the codes and standards. So what I can understand, what I can infer from here, that in this load combination, which is generated automatically by the software, they have ignored this condition. Why they have ignored, I do not know. Maybe they thought that this is a conservative approach, which is more conservative, so why should I take a 0.5 L? Very good answer, but in some cases, it's a better idea to have 0.5 L where your live load is excessively high, but then your structure will not be very economical. Rather, I can say it will be a little bit uneconomical if you are designing for a higher load, which is not needed. And the logic is, in case of an earthquake, this structure will not be fully loaded with live loads, with the design live load, I can say. So they should think logically. Live load means, design live load means the maximum expected live load on this floor or on this structure. In case of an earthquake, there are even chances that maybe only 25% of the live load is present. 25% of the design live load is present. So code provides that, okay, you can use that live load, but go only 50% of the design live load. Don't take the 100%. Where on the structure, in case of an earthquake, there will be 100% live load. That means they have ignored a very, very essential combination where I can say that because of that, in case of higher seismic zone, my structure will be a bit uneconomical. It will be conservative, but that conservatism is not needed, and this is not the reality. In reality, my live load will not exceed more than 50%. So please, if the developers of ETABS, they are listening this video, they are watching this video and they are listening to me, I will suggest them to give a choice. Like maybe they can give a choice by a checkbox whether you want 0.5 L or 1 L, and then they should generate as per that one. Either I am interested in 0.5 L or I am interested in 1 L. This is very important thing. Otherwise, if you do not understand this, that means your input is garbage, and whatever you are going to input, that will be a garbage in and garbage out. But if you are a real structural engineer, you should understand that how to control my software. A structural engineer should not be the slave of a software, rather a software should be his slave. He should know how to control the software. He should know what he has to do with the software so that the actual scenario should be modeled mathematically. So let's go back to the problem. Now all the loads are defined over here and the load combinations are there. So now in case of designing the beams, what are the requirements? So here are a detailed list. This is the summary of the requirements for beams and one-way slabs and building assigned to SDC A or B. Like for example, serviceability. It says that the minimum thickness should be according to table 9.5a. Method of analysis, it says that you should follow the section 8.3.1, 8.3, 8.2, 3, etc. When you are designing the member for flexure, you must provide minimum reinforcement as per 10.5.1. You can take the net tensile strain as 0.004 as per 10.3.5. For the spacing, you should follow 10.6 and 7.6. Positive negative reinforcement, para 12.10, 11 and 12. Structural integrity, 7.13 as we discussed. And then very important thing is the lap length. As per equation 12.1, you must provide proper and adequate lap length. So do not forget to check this. This is a special requirement. So development length is there. Development length continued. All these conditions you have to check as per the code and standard. I'm not going to detail each and every lap length over here. You can calculate easily, and the section is provided as 12.6. Then splices, you have to follow for splices para 12.14, 12.15, 12.15.2, 12.15.1, etc. Confinement, as mentioned before, that compression reinforcement in beam shall be enclosed by ties. Reinforcement of flexure reinforcement subject to stress reversals or to torsion shall consist of closed ties. So confinement is very important for the compression members or fracture members also, but for the compression reinforcement. So that's also very important thing. Then you have to check shear. All the requirements for shear you have to check. And that should be done according to section 11.11.1, 11.2.1 and 1, and all this chapter 11 for shear should be checked. For torsion also 11.5.3 or 11.5, you have to check the torsion conditions also. So these are the minimum provisions you have to follow as per the codes and standard, and you have to verify that you are meeting all these conditions in your output. And if there is something which is not met, then you have to calculate manually and you have to provide. Or in your design report, you should say that yes, I met all these requirements. So similar provisions are there for the slabs. Of course, the conditions, they are very similar to the slabs, no need to repeat, and for the columns also. My emphasis is, what I want to make you understand, that if you are designing a structure in SDC B or A, then you have to follow these requirements. When I will design a seismic category C structure, then I will explain what are the additional requirements you have to follow. And similarly, I will develop another lecture where I will explain if the structure is in SDC D, then what you have to follow. So what will be the additional requirements if the structure is in a high seismic zone. But for seismic zone A and B, of course, these are low seismic areas. Seismic A is very low, no need to do any special thing. But for seismic zone SDC B, where it's a little bit higher seismic area than A, but of course mild seismicity, then at least you have to check the proper ductility, structural integrity, and the lap length, etc., so that there should not be any catastrophic failure. Please do not hesitate to ask me any question. I always welcome questions from my viewers. Although I am receiving a lot of queries and requests from, especially from young engineers all over the world, I do appreciate their effort, and I am always there to help you. So please do not forget to subscribe my channel. say thank you, and I'll end my video at this moment. So thank you very much.